All right, listeners, buckle up. Today, we're going deep on something you probably never thought you'd find fascinating. The design of dental implants.
Oh, yeah. It gets way more interesting than you think.
You guys sent us a ton of research on this, so we're skipping the Implant 101 stuff you find everywhere.
We're talking the nitty-gritty choices behind what goes in your mouth permanently.
It's engineering, but on a seriously tiny scale.
And it impacts everything. Healing, how long they last, even how your gums look. Huge decisions, even if you don't see them.
So the research says over 95% of implants are successful long-term, which is amazing, but it makes you think.
Makes you think, what about the other 5%?
Exactly. And what separates just good from a truly great outcome.
And that's where design comes in. This source shows some wild early shapes, blades, frames, even ones going through your jaw. Imagine that. Makes you appreciate how far we've come.
Big time. Okay, so let's dive into modern implants. We'll break it down into two levels, macro and micro.
Love it. The macro is the big picture, shape, structure, that kind of thing.
Right, like our source really gets into body shapes, especially the debate. Parallel versus tapered implants.
Big debate.
Yeah, so parallel is the same diameter top to bottom. Tapered is wider at the top, narrower at the bottom.
Exactly. And it affects how well it fuses to your bone.
So it's like picking between a straight peg and a wedge. Seems obvious the tapered one would be more stable?
Not always. Both have their ups and downs.
Yeah.
Parallel has consistent surface for bone contact, which can be good in certain cases.
Okay. But I can see the tapered one being more stable right away. More contact at the top.
You got it. That initial stability is key. And tapered ones can often spread the load better, too. You know, when you bite down.
Load distribution, right? The source mentioned that. So, like, the force spreads out instead of stressing one spot.
Exactly. Important for long-term success. And with tapered implants, you can sometimes even brace them so they avoid certain structures.
Ooh, makes you wonder what structures.
Right. Lots to think about.
This is making me think about something else the source talked about, neck design. And this tiny space called the microgap.
Ah, the microgap. That can be tricky.
Basically, it's this tiny gap between the implant and the part that connects to your crown.
And if bacteria get in there, trouble, inflammation, even bone loss around the implant.
Yikes.
So neck design matters, especially with tissue-level implants where that gap is above the gum line. Makes it tough to adjust the angle once it's in.
So you got to get it right the first time.
Like setting a fence post.
Ah, good analogy.
Yeah.
And speaking of connections, our source talks about external and internal ones.
Crucial part of the design.
Looking at the pictures, external ones look kind of flimsy, like they could break off easier.
Looks can be deceiving. Internal ones are way stronger. Abutment fits inside the implant. Force is spread more evenly.
Less stress on everything. Makes sense.
Yeah. And even the way the abutment clicks in varies indexed or non-indexed. More engineering than you think.
Wow, a whole tiny world of mechanics going on in there. Okay, let's talk threads. The source mentions Wolff's Law. Basically, bone gets stronger when it's stressed.
It's true.
So the implant threads are like making your jawbone lift weights.
Kinda. Yeah. But too much stress is bad, so thread design is about finding the sweet spot for bone growth. Not too much, not too little.
Just right. And different thread shapes can actually make different types of force.
You got it. Compressive, tensile, shear. It's all in how those threads interact with the bone.
So it all connects back. Okay. Implant shape, threads, the forces they make, like a whole symphony in your jaw.
And we haven't even gotten to the really tiny stuff yet. That's where things get super interesting. Yeah, macro design sets the stage, but when we zoom in on the surface, that's micro design. That's where it gets really crazy.
So we're going from architects to, like, jewelers at this point.
Exactly. And the material matters big time. Our source is all about titanium, which is basically the king for implants.
Why titanium, though? What makes it so special for this?
It's amazing how well it gets along with the body. No weird reactions. Biocompatible, that's the word. And a lot of it comes down to this thing called the oxide layer.
Oxide layer. So it, like, gets a little rusty?
Not quite. Think of it more like a microscopic force field. Titanium, when it's exposed to air, instantly grabs oxygen molecules. And it forms this protective layer, like a shield. Keeps ions from the metal from leaking out, which would irritate your tissues.
So it's protecting the implant and my body at the same time. That's pretty cool.
Right. And it does even more. That oxide layer, it attracts water molecules, and they split apart, leaving these things called hydroxyl groups on the surface.
Okay.
And those are basically like tiny welcome mats for the proteins that have cells attached to the implant.
So it's not just a shield, it's like rolling out the red carpet for the cells that are going to help it fuse with the bone.
Exactly. And then there's surface roughness to consider. Rougher the surface, better the bone can grab on.
Yeah, the source had all these terms for it. Machined, sandblasted, acid etched. Sounded like making a whole landscape on the implant.
And each technique creates a different level of roughness. That affects how well bone cells attach, how fast it integrates, like creating the perfect climbing wall for those cells.
Love that analogy. And some companies are really taking this roughness thing seriously.
Oh, yeah.
The source mentions Straumann's SLA and SL-active surfaces. Those seem like the top-of-the-line stuff.
They are. Cutting edge, really maximizing that bone integration, locking that implant in good.
So we've got the bone covered, but what about the gums? Got to keep those healthy up there, too.
That's the million-dollar question. Our source actually makes this cool comparison to nature.
Who?
Think about hair, nails, even that weird Barbarossa tusk that grows right through the animal's skin. Nature knows how to make things poke through tissue without infection. Can we do that with implants?
Good question.
Right. And researchers are trying all sorts of stuff. Flanges, grooves, different levels of porosity, coatings. It's like a race to crack the code of soft tissue integration.
And high stakes, too, I bet. If you could get the gums to attach really well, seal tighter on the implant.
Game changer. It would mean healthier implants, better aesthetics, too.
Yeah, no more of that gray line you sometimes see around implants, just healthy pink gums.
Exactly. And there's some hints that the future might be something that can calcify, like the cementum on our natural teeth.
Whoa! So the implant would basically become part of your mouth, not just sitting in it.
Now that would be amazing. But for now, we're still searching for that perfect solution. Even with all the micro design advancements, keeping things sterile is still a big deal.
I guess bacteria are always going to be lurking no matter how high-tech we get.
That's why keeping your mouth clean is so important. Best implant in the world won't do much if you're not taking care of things.
It's a team effort, really.
Yeah.
Implant does its job, we got to do ours.
Absolutely. And that leads to another fascinating aspect, how implants handle the forces we put on them daily.
Chewing, biting, all that. How do they even measure that? Are there, like, tiny pressure sensors inside?
Not quite. A lot of it is biomechanics, the science of how forces act on living things. Researchers use computer simulations, mathematical models, to see how different designs hold up.
So they can kind of predict how an implant will do before it's even put in someone's mouth.
To a degree, yeah. Of course, everyone's different. But this testing lets us design implants that are much more likely to last.
This is so much more complex than I ever realized, seeing why you're so into it.
I know, right? Where else do you get biology, materials science, and good old engineering all rolled into one? And speaking of materials, remember zirconia?
Yeah, the one that's super strong, but maybe has some issues breaking down over time. What was that called?
Low temperature degradation. A bit of a mouthful, but researchers are watching it closely. Seems like under certain conditions, zirconia can weaken slowly when there's water around.
Uh-oh. And the mouth is not exactly a dry place.
Not at all. And we need implants to last for decades, hopefully a lifetime, so it's a consideration.
So is zirconia risky then?
Not so simple. It's got a lot going for it. Strong, looks good, generally biocompatible. The degradation thing is a concern, but not a deal breaker necessarily.
Right.
New types of zirconia are coming out all the time that are more resistant. And there are ways to lower the risk with careful planning, choosing the right patient.
So a balancing act, weighing the pros and cons for each person.
Exactly. And that's why talking to your dentist is key. Ask questions. Make sure you understand the options.
This whole deep dive has been mind-blowing. Never thought I'd be so fascinated by dental implants.
It's a testament to all the researchers and clinicians out there.
Yeah.
Always pushing the limits to make things better for patients, really changing lives.
Seriously, it's incredible what they're doing in this field.
It is, and it's constantly evolving, which brings us to something that's really taking off. Personalized implants.
Personalized implants, you mean like
Yeah.
custom-made, tailored for each person.
Exactly. Using advanced imaging and computer design to create an implant that's perfect for your anatomy.
Sounds like sci-fi, but I guess that's where we are with tech these days.
Right. Imagine an implant that fits perfectly in the space where your tooth was. Ideal shape, size, even the surface texture, just right for your bone and gums.
So no more guesswork about whether it'll fit or if there's enough bone. Sign me up.
We're not quite there yet, but personalized implants have huge potential. Could really revolutionize the field.
Wow. Okay, let's come back to reality for a sec. The source also talked about something called platform switching. What's that all about?
Platform switching. This is where you use an abutment that's actually narrower than the top of the implant.
Wait, wouldn't you want a wider one? For more support. Seems counterintuitive.
You'd think so, but what they found is that narrower abutment shifts the bacterial seal. Remember we talked about that?
Yeah, keeping those bacteria away from the bone.
Right, so it moves that seal further away from the bone, extra layer of protection.
Sneaky. And it helps the gums too, right?
Yeah, there's evidence it can make the gums look healthier, more natural. The way the crown emerges is nicer.
So win-win. Better
Yeah.
for the bone, better for looks.
Pretty much. Not perfect for every case, but overall, the benefits are there.
It's crazy how these little tweaks can make such a difference.
It is. That's what's so cool about this field. It's biology, materials, and good old-fashioned engineering all working together.
We've covered a ton today. Macro design, micro design, titanium, zirconia, even those futuristic personalized implants.
And hopefully, you all have a new appreciation for what goes into these things. They're truly life-changing for people.
I know I do. And next time I see a dental implant, I'll be thinking about all that hidden stuff going on inside.
Yeah.
Keeping it healthy, doing its job.
That's what it's all about. And if you're ever thinking of getting an implant, remember, knowledge is power.
Ask questions. Don't be shy. Your dentist is there to help you understand the options.
Exactly. It's your mouth, your health. And now you've got some serious knowledge to help you make the best choice.
This deep dive has been amazing. Truly mind-blowing stuff.
It has been fun. Thanks for joining us on this journey into the world of dental implants.
It's a world I never thought I'd be so interested in, but here we are. Thanks for listening, everyone.